Okay, so good afternoon, everybody that's on the call right now. I don't think we're starting now. And good afternoon also, Engineer Walter. Really happy to have you on the call. So we are
Good morning,
still,
good afternoon, your time. Nice to be here. Busy day ahead. I'm sure, I don't know, there's some football guys here too, so it's going to be a long day for me, anyways. So,
thank you very much, sir. Thank you. So while we're still waiting for more people to join the call, um, we'll just wait for them to join the call. Maybe we'll start like 5 minutes. 5 minutes. Let's give them 5 more minutes. Okay, so we'll be starting now. Good afternoon, everyone. Welcome to our highly anticipated webinar, Empowering Youth for Climate Action, Integrating Environmental Education and Energy Sustainability. Okay, so without wasting any of our time, starting off today's event, we'll be having our welcome address by the president of SP FUTSMINA section.
All right. Thank you very much, Mona. Please confirm if you can hear me, please. Can you all hear me?
Recording in progress.
Yes.
Yes, we can hear you.
All right. So, thank you very much. Thank you very much, Mona, for that. And I want to appreciate everyone for joining this call. Good afternoon. My name is Mutosholo Adamlala. I'm president of SPU FUTSMINA chapter. I want to welcome.
Sorry, Dami, I think it's a network issue because I'm not hearing from my side.
Can you hear me?
Okay, I can hear you now. Please go ahead.
All right. So thank you. I'm going to make it very brief because I'm actually in transit. So thank you very much. And I'm so sorry if there's any network issues. So as I was saying, this is going to be an engaging session. We are known to be future leaders and we need to be observant. We need to know things about our environment, about the climate. So environmental education is very, very important. And we are glad we are gathered here to address this very important issue facing the world: climate change, environment, energy sustainability. So thank you very much. I want to acknowledge the presence of our speaker. He has been on this call like 15 minutes to the time. Please, a virtual upload for him. He has been on the call 15 minutes to the time. That's to show how committed, how willing he is to teach us, to speak to us this evening. Please, let's give him a virtual applause. So I want to appreciate the chapters present on this call, the FUTSMINA chapter executives and members, the Rotary chapter executives and members, and the Nile University chapter president and members. I want to appreciate everyone. So remember, we are gathered here to learn, to grow together, and to also network, build our connections. After this call, I want to encourage everyone to reach out to the speaker on LinkedIn, connect with him, and also learn from him.
So we're supposed to travel to Morocco.
Please let's. Okay, so
Sorry.
that's been said. Okay. Right, with that being said, I would like to welcome everyone once again, and I would like to encourage us to engage ourselves. Get your pen, get your journal, jot down when necessary, participate, and ask questions when necessary. I wish us the best. I wish us the best, and I want us to.
No, it's
okay.
not school.
I want us to
They
learn once
don't
again.
allow.
Sorry,
Please,
sorry, iPhone 11 Pro Max. Please, can you mute your mic?
All right, that would be all
So
for
we
my
talked
end.
to the manager.
So
He said no.
I'll give Mona. Please kindly go ahead.
Okay, thank you. Sorry, please, could one of the hosts please kindly mute iPhone 11 Pro Max?
Recording stopped.
Okay, so thank you very, very much, President FUT Mina session, for that welcome address. Very bad etiquette for me at first. I didn't introduce myself. I'm Amodu Enemona John. and I'm your moderator for today. So welcome again, everyone, to this exciting event and session. So moving on, we'll be having our safety brief. Calling on Melissa Kuma to take us on that. Over to you, Melissa.
All right then. Good afternoon, everyone, and welcome once again to this technical event. Welcome to our guests and, of course, our amiable hosts. It's an absolute pleasure to be in attendance. All right, so straight to the order of the day. In line with SPE's initiative of always being safety conscious, we would like at this juncture to remind everyone in attendance of a couple of things that will ensure that we are all kept safe in the course of this technical online event. 1, raise up your hand to speak. 2, ensure that you can hear the fire alarm with your headset if you are using a headset. 3, mute your mic when you are not speaking so that we don't have any issues of distractions in the course of the event. 4, use the chat for comments and questions for orderliness. 5, always stay safe. 6, be alert. 7, maintain a good sitting position. And in addition to this, if you are driving, if you are cooking in the kitchen or whatever you might be doing, please ensure that your handset is not anywhere near anything that could pose a safety hazard. In all, please enjoy the event. My name is Melissa Ekuma. Thank you very much.
Thank you very much, Melissa. Virtual round of applause for her, please. Thank you very much. Moving on, our next section is the icebreaker session, and I'll be calling on Wisdom to take that please. So, Wisdom, if you're on the call, over to you, sir.
Yes, I'm here. Good afternoon, everyone. Yes, my name is Wisdom, like Radley said. Put me now. And so we'll be taking the icebreaker session. Well, the icebreaker session is a chilling time. I just like us to participate, let's relax, then answer questions. Thank you. So the questions will be displayed on the screen, and then we'll type in our answers in the chat box. Okay, so I just have 5 questions for you. No one have children. So the first one, what's the full meaning of NAICE? NAICE. Can you confirm you can hear me?
Yes, Wisdom, we can hear you.
Recording in progress.
And so the questions are on the screen. Just type in your answer on the chat box. First one, the full meaning of NAICE.
Sorry, Wisdom, I don't think they got the instructions for the game. Could you go over the instructions again? I think your network was a bit.
Okay. Can we hear me now? Okay, now the icebreaker session. I'll be asking you some simple questions, and then you have to type in your answer on the chat box. So if you know it, you type in your answer on the chat box. Hope we are clear with that now. So the first one, okay, I think there's a response. First one was the full meaning of NAICE, nice. Okay. Second one was the full meaning of OBO in the oil and gas industry? Yes. Yeah, I've gotten my correct answer for the first one, the first question. Okay, so yes, I've gotten my correct answer. Other business operator is the correct answer. And then next one, FRSC. Okay, someone has already answered that. Okay, so we'll go to the next one. Okay, can you move to the next question, please? Which of these countries are about to use 100% renewable energy by 2050? Afghanistan, Kenya, all of the above, Guatemala, and Vietnam. Thank you. The next one. Is the response ready? Please move to the next question.
Recording stopped.
All of the above is correct. So the next one, please. Next slide.
Okay, I think there's a network problem with Ume. I think she's having network issue. Maybe we should just wait on for a little while. She'll come back, and then she'll be able to share screen with us once more.
Okay, so can I read the question from my end, or just wait for her?
Okay, if you can read the question from your end, there will be no problem, please. That will be superb.
Okay, fine then. Yes, so all of the above is correct for the previous question. So the next one, what is the oldest form of renewable energy? What is the oldest form of renewable energy? I have wind, solar, geothermal, and hydropower. What's the oldest form of renewable energy?
She was so friendly. She's always been like this.
Sorry, please can we mute our mic, please?
They are not expecting.
Hydropower is very, very correct. Okay, so
You can speed it up. Our speaker will be having a meeting in the next 15 minutes. So if you can do this quickly, so we can get on.
Okay. Between carbon dioxide, methane, and water vapor, which of the following is a greenhouse gas? Carbon dioxide, methane, water vapor, all of the above. Which of them is a greenhouse gas? And that will be my last question. Just take that. All right then. Yes, all of the above is correct. Both methane, carbon dioxide, and water vapor are greenhouse. Thank you so much. So that brings us to the end of the icebreaker session. Just relax and enjoy the rest of the program. Thank you so much.
Thank you very, very much, Wisdom, for that wonderful icebreaker session. I'm very sure most of us here learned one or two from the icebreaker session. So going further, for our next session, we have the introduction of speaker, and we'll be calling on Collins to take that for us. Miss Collins, are you on the call?
Recording in progress.
Is Collins on the call? Okay, it seems Collins is not on the call and the slides are not being displayed. We can call on the president's footnote section to please introduce the speaker for us. Is she on the call?
Can you hear me?
Yes, we can hear you.
All right. So I guess there's a network glitch from Claire. So I will be introducing the speaker because the speaker has a meeting in the next few minutes. So not to waste the time of our speaker, I'll be introducing the speaker briefly. So just give me some minutes, please. All right. So Mr. Walter Eweze stands out as a seasoned environmental engineer with a diverse background spanning manufacturing, technology, and oil and gas industries. His leadership and networking prowess were notably displayed during his tenure as the president of the Society of Petroleum Engineers, SP, at Society of Petroleum Engineers at Obafemi Awolowo University, OAU. Please, a virtual applaud for that in 2015. Furthering his commitment to the field, he holds the position of Young Professional Chair for SPE in the Permian Basin, Texas. Walter's professional journey includes significant roles at ConocoPhillips, and he has contributed his expertise to leading corporations such as ExxonMobil, Amazon, and Cummins. His academic credentials are equally impressive, with a degree in chemical engineering from OAU, a Master of Science in Environmental Engineering from Texas A&M, and executive education in environmental sustainability from Harvard School of Public Health. He also has a certified skill in advanced data analytics at the University of Texas Business School. Waters multi-phased experience and education make him a valuable asset in the field of environmental engineering. Also, an SPE Africa Regional Awardee. Please, a virtual applause for our speaker for today's event. Please, Mr. Walter Ebweze, you can have the floor. We are glad to have you on the call. Thank you very much.
Yeah, thanks for the introduction. Good morning, my time. I think it's afternoon or evening. I don't know if you guys can hear me.
We can hear you very well, sir. And go ahead.
Okay, I hope I can share my screen because I know. Let's see.
Yes, you can. You've been okay. Yes.
Okay. Can I minimize this? Okay. So like I have a few minutes. I was thinking I'm going to start early than this because it's a busy day for me. There's another SP event I have, and also meetings here. So I'm an environmental engineer with ConocoPhillips currently, and I've worked for different companies. So today we'll just focus on climate change and youth empowerment. I'm just focusing on what I got from the invitation I had. So I'll just quickly run through. Can you see my screen?
So, yes, sir, we can see your screen.
Okay.
We can see your screen.
Okay. So run through this action for climate empowerment, environmental education, and we end with hazardous waste. I will try and hit some salient points because of time constraint. Okay. So I know most of us know about the COP28, COP29, which was held this year. So for this topic, we're focusing on education and training, right? So youth empowerment. So the action for climate empowerment pretty much adopted by United Nations. And of course, this was under the Article 12 of the Paris Agreement, right? So pretty much there are a lot of bullets here. You have education, you have public awareness, you have training, you have public participation, you have public access to information, and you have international cooperation. And under the international cooperation, that's where you have the COP program, where you have a lot of companies and also a lot of nations who are actually pushing the envelope for climate change. So for, like I said, for this conversation, we'll just focus on education. So I don't know how many of us are into environmental science here or are kind of interested in green energy. So public awareness initiatives are very, very key. You know, pretty much platforms like this, different organizations raising that jingle, awareness of climate change is very important. But added to that is education. So most people, if education being maybe attending webinars, maybe studying that course, being an environmental scientist, or also educating the public. It could be community awareness. So that's really part of it. When it comes to like recycling, keeping the environment clean, waste management, that could be part of awareness and making sure we don't have our drainages clogged and all that. It's hard to start from somewhere. So it doesn't have to be like the biggest scope. You could start from the little resources you have there. Then training is key, and training, but I would tie training with funds. If there's no funds, then it can't be training, because most times some countries, unlike the countries in the West here, where there's a lot of commitment by Department of Energy or by the EPA or by NGOs, giving those trainings to people who want to really have those skill sets. And so a typical example could be interpreting the climate data. Data analytics is almost pretty much important. But you need to have that training to be able to understand how the data could impact long-term and short-term. So, like I said, the recent COP29 this year, thank God, everybody's looking at, they're trying to triple the funds, right? To some nations, a lot of nations who are thinking, like I said, if there are no funds, you can't push the envelope. We can talk about training, education, awareness, but what drives the envelope is finance, right? So this year, they all agreed to, the UN at the COP29 agreed on tripling the finance from $100 billion to $300 billion annually by 2035, which is a good step in the right direction if you're going to achieve our climate goals. So another thing they're trying to do is secure all efforts of all actors to work together to scale up finance. So it's very interesting now that the awareness is there. Hopefully, again, a lot of things could impact this. We just had the United States election. Leadership, geopolitical play could impact this. But again, the UN has its own power to do all this. Again, the focus is to help underdeveloped countries to meet their climate change goals. So I don't think a lot of the political play in the West will impact whatever funds will be going into that. So, but this is one of the new developments when it comes to climate change action. This just happened like 2 weeks ago. So how can we, or how can the young professionals contribute? There are a lot of things. I know in the oil and gas, we have carbon capture, direct air capture, and everything is tied towards climate change as hazardous waste. So I'm going to walk us through real quick in the next 30 minutes, some of this carbon. I know you know what CCUS, carbon capture and carbon capture storage. So that's what CCUS means and CCS. So understanding the economic risk of carbon. So again, for every technology, there's always an advantage and disadvantage. So it depends on, every company has their own goal. Every company has their own 2030, 2050 vision on where they want to be when it comes to carbon mitigation, or some companies, that's not even their goal. Some are just focused on methane, greenhouse gases, some are on carbon. So it's gradually been a jingle now in the oil and gas industry. So that's focus on the economic risk, long-term and short-term. And technologies are part of the economic risk. How would this technology impact our business and all that? So the same thing, know the technical and economic trade-offs for CCUS and CCS projects. That's also very important. Engaging with policy and things. So it could be the EPA, it could be the, like in Nigeria, it could be DPR, if companies are going into carbon capture storage. So those play also impact decision making. So, but how can how can the young professional, the youth, put that? I think understanding the technology, understanding the technical know-how of how this technology works and the impact, especially if you're going to be an intern in a company and you're trying to propose what are the risks. So you just want to propose carbon capture storage. I feel this could work. You have to really look at the economics. Is it something the company is looking at now, short term or long term? Is it important for the business? So then the regulatory aspect of it. Yeah, if it's not, like I said, DPR, I don't know what DPR is doing in Nigeria. I'm not really confident with the regulations like that. But if I'm talking about the United States, yes, it's a big deal. Department of Energy is funding carbon capture utilization. So all those things play a key role. Scope 1, Scope 2, Scope 3. I don't know, have we heard of this before?
No, sir.
Okay, so Scope 1, Scope 2, Scope 1 and Scope 2, these are the major emission stand, pretty much, greenhouse gas. That's what, you guys, I'm sure you're aware of methane and CO2 and the likes. So there are a lot of greenhouse gas is out there. So in the global sphere for environmental space, Scope 1, Scope 2 emissions are big. These are direct emissions and indirect emissions. So an example might be a combustion from producing facility, from a boiler, from a furnace and vehicle. As we continue this presentation, I'm going to do an example. We'll show you something on how we reduce emission. You see two facilities, but more on a model.
Sorry, Ifoma, Lucy, please can you please mute your mic, or any of the hosts can please mute his mic for me.
Scope 2 emissions are indirect emissions, just like you have in your house. You purchase electricity, right? That's scope 2 emission. Your heater, your cooling, your AC, they are indirect. Scope 3, just like managing waste. I will show you that down the line, what a scope 3 emission looks like. So how can we help? How can young professionals? I always like using the we. I'm also in that bucket list, right? Understanding the scope 1, scope 2 emissions are really key. Like I said, emission forecasting projects are very, very key. Participating technologies that track scope 1, scope 2. You have methane detectors at facilities. Methane is one of the highest greenhouse gas we always focus on. SWD means salt water disposal facility. So, like in the oil and gas, you have your water, you have your oil floating in it, and you have your gas. So the water, how do they treat? So we have injection wells where they put those. Most of them are class 2, some are class 4 wells. It depends on the country. I know in the US, some of them are really regulated by the EPA. So saltwater disposal facilities are very, very key. Also, when we're tracking those, because most of them still have like embedded in one of them will have some little of those offset gases. Water chemistry and compatibility testing and completions is also key. Produce water treatment project. So it be it municipal water, is the water going to be used for reinjection into the formation? Is the water going to the states? So you want to be sure that your effluent stream. So normal water treatment, there's a primary stage and a secondary phase. Most people just focus on the coagulation, flocculation, filtration, and chemical injection, that's chlorination. That's what we are common with. But the secondary stage is very important. That's where it's more the advanced treatments, especially when it comes to produce water that has chloride ions and it has your heavy metals, your calcium and magnesium, or your TSS, your BOD. You're focusing on putting your membranes or your reverse osmosis system to beat down to reach those limits, effluent limit that will not contaminate the environment. So that's part of it. So that's a big chunk in the oil and gas. You want your water overboard. I know, like for offshore, it's really big. Like your water overboard has to meet some standards. You don't want to have pollution. You don't want to kill livestock in the sea. So that's why water treatment is very good. I know most companies use hydrocyclones, which are good, but there are advanced technologies now out there. Another aspect for climate change, another technology in the oil and gas that have we heard of DAC, direct air capture? I know some people must have heard about it.
No, sir.
Okay, direct air capture. So it's still new in the oil and gas. Companies like Occidental Petroleum have been championing it. So direct air capture simply puts you're pulling out atmospheric air through series of chemical reaction and extracts your CO2. So again, here you have a greenhouse gas. So this is one of the greenhouse gases that's very, very key in climate. That's very, very high top of the chain. So again, the goal is to extract atmospheric air directly, and through there are a lot of chemical reactions. I will show you a video if there's time on how it works. So pretty much, normally for CO2, we say there's what most plants and trees do every day by photosynthesis and accept does it much. So you are comparing your natural means versus your artificial means by implementing a system. So it's faster with direct air capture technology than using your normal plant. Although planting trees, I know in other countries we try to reduce carbon by tree planting is good, natural means, but it's faster with this technology. Let me see if this is going to play and if you guys can hear. And then on call of time, I will have. Let's see. Okay, it was. Can you guys hear?
No, sorry. The audio hasn't come up yet.
Can you hear?
Not at all, sir. I can't hear anything from my.
Can you hear?
No, sir.
No, sir, it's
Okay,
not coming up yet.
I know what the problem is. So it's I know what the problem is. Sorry, I was going to Zoom. I'm trying to go back to your Zoom, and there's a setting you're meant to have done. Okay, minimize this. Oh, yeah. So I'm meant to go to, let me stop sharing. I just wanted to understand when I go to share sound. Okay. Can you see my screen?
Yes, sir, we can see your screen,
Okay,
sir.
so now, yeah, I've just worked on it now. So it should work now. It's refreshing. Can you hear now?
Direct air capture, or DAC, is an important technological
Yes, we can hear
solution for removing
the audio
carbon
now, sir.
dioxide from the
Okay,
atmosphere. We believe carbon engineering's technology is capable of doing this at an industrial scale. This approach combines proven processes to remove large volumes of carbon dioxide from the atmosphere year over year, enough to help us curb global temperature rise to 1.5 degrees Celsius when combined with other global carbon reduction initiatives. The premise behind DAC is simple. Air is pulled into the facility with dozens of high-powered fans and sent through a series of processes that separate the carbon dioxide from other atmospheric molecules. The isolated CO2 is then converted into a liquid, which can be pumped underground to be safely and permanently stored, or used as a feedstock for products that improve our quality of life. A DAC facility will have large fans that draw air into each unit, where it is absorbed into a chemical solution of potassium hydroxide and water, which bonds to the CO2. This bonding happens as the potassium hydroxide flows across a highly engineered PVC packing system designed to increase the surface area and amount of CO2 captured. Once the liquid solution reaches the unit's outlet, the process of concentrating the captured CO2 begins. First, the solution is pumped into a piece of equipment called a pellet reactor. Calcium hydroxide is added, forming small pellets of calcium carbonate that hold the captured carbon. The pellet liquid solution is pumped into a centrifuge, where the pellets are separated from the refreshed potassium hydroxide. The pellets are then dried, while the potassium hydroxide liquid is filtered and recycled back to the air contactors to capture more CO2. From the centrifuge, the calcium carbonate pellets are moved to a calciner, where they are exposed to high temperatures and converted into calcium oxide and carbon dioxide. The captured carbon dioxide is sent off to be compressed and either stored or utilized. The calcium oxide pellets are recycled back into the process. They are first sent to a slaker, where mixed with water, calcium hydroxide is formed and ready to go back into the pellet reactor, where it will be used again to create new calcium carbonate pellets. With the CO2 captured, separated, purified, and compressed, it can be permanently stored deep underground or used as a feedstock for new products such as cement, plastics, or even low-carbon fuels. Carbon engineering's DAC technology utilizes widely deployed equipment and processes in a new way that will help reduce atmospheric CO2 concentrations at scale. DAC has the potential to remove large volumes of CO2 from the atmosphere and create carbon removal credits that could help us achieve global climate and net zero targets. One of the most exciting things about direct air capture is that when deployed at a large enough scale, it may even help us achieve a net negative world by removing more carbon dioxide from the atmosphere society emits, supporting a sustainable climate as the world continues to grow.
We're 1.5, and we make a difference.
Recording in progress.
Hello.
Yes, sir, we can hear you. We can hear you
Okay.
now.
So did you guys see the whole simulation, how it works? Just like what you see here, that's exactly what the video is talking about. So pretty much that's another greenhouse gas technology apart from carbon capture and all that. So this direct capture technology is kind of in play now. It's only in the Permian Basin. Popular company like Oxy Petroleum does that. They've been pushing down. It's part of the climate change solutions. And would I say carbon capture and direct air technology, which one is more expensive? Which one do you think will be more expensive?
I think the direct would be more expensive. Direct,
Okay.
sorry, indirect.
Okay, let's see. Let me see if I have time to answer that. So the process, like we said, this is the process. The process of DA involve giant fans, like you can see, pulling CO2 to a system, and you saturate it with CO2 and they undergo regeneration process, pretty much. And the CO2 is purified and securely stored on the ground to prevent from re-entering the atmosphere. So it's almost like the way you have carbon capture. The only thing that carbon capture might not require real estate. So that's the only difference I would say. The air capture will require a lot of, you can see it requires a lot of system, right? You have to, like, you require, like, setting up a like land, you need a lot of real estate to set up this on the facility with all the reactors and all that. Like carbon capture, you don't need all that expenses. Pros and cons of, like you said, reduces atmosphere, requires smaller footprint, can achieve net zero or negative emission. Disadvantage, requires large amount of energy. So that's your answer. Yeah, like you said, it require a lot of energy to pull that CO2 into that system. So I don't know how big the kind of design of the fans you will need. You have to consider the rotor, consider the energy and all those things. So it's currently very expensive. So compared to carbon capture. Yeah. Just like what I was trying to discuss with say earlier, that we'll see further. So these are the environmental impact of direct air capture versus carbon capitalization and storage, right? So while carbon capture focuses on CO2 emissions from industrial, direct air focuses on atmosphere. You can see the difference there. So carbon capture is focused on industrial, while of course DAC is from the atmosphere, which by the video you saw that. So what does the future hold for us? I'm trying to breeze in quickly because of time. Carbon capture technology are expected to be crucial as we strive to achieve climate goals. Yeah. The development and deployment of direct air capture facilities are on the rise, offering a permanent storage. So like I said, it's something new, Occidental Petroleum. If you want to read more about it, check Occidental Petroleum direct air capture. So there you have it. Which one is more expensive? They are both good for climate change, but hey, one requires from the atmosphere, one requires from industry. So I'm going to breeze into environmental space. So I'm focusing on I'm focusing on education. You have to understand education and training is key. Just like what the AC said, you can't really be impactful as young professionals without understanding those technologies and how you can make that change, right? And again, another thing, like I said, funding is important. It involves a lot of costs, as you can see on the slides in terms of technology. Hazardous waste. For air, you have VOC, volatile organic compounds. You have greenhouse gas, and which are under you have CO2 reduction, or spill reduction. So I'm going to focus on hazardous waste because of time. Emissions, VR, I was going to talk about, but let me just go to hazardous waste management. So I know we are used to reduce. I don't know if you've heard of 4 hours before. Has anybody heard of 4 hours before?
Yes, sir.
What?
Yes, sir.
Okay, and maybe at a similar. So it's more of energy recovery. So why I would put the fourth R is because of what we're talking about, energy recovery, sustainability. So normally we are used to reduce, reuse, recycle, right? So the energy recovery part of this is very key. So hey, we are trying to reduce greenhouse gas. You see, we're talking about greenhouse gas. Most of the climate change, you're trying to make sure that CO2 reduction is to what the COP28 and 29 is talking about, in terms of 1.5 degrees Celsius. So again, you can see everything is talking about CO2 greenhouse, CO2 methane, CO2 and zero landfill talking about methane reduction. So that's why we have hazardous waste management. It's key to have the energy recovery. You don't want to ensure your landfill has zero methane gas. So let me move to the next slide. So, but how do we achieve the 4 R's? Like the fourth one, there are 4 R's: reduce, reuse, recycle. Well, the fourth one is called the energy recovery, right? So waste stream audits and sustainable strategies are key. Equipment and industry relationships too. Expertise end-to-end liquid waste treatment. I'm going to show us another video. So waste to energy, this is what we want to talk about, sustainability. You see, annually diverts to 2.22 million tons of greenhouse gases to carbon equivalent of removing more. So imagine looking at post-COVID and when COVID happened, right? A lot of cars reductions on the road, people were working remotely. So that is part of it too. But in terms of hazardous waste, energy recovery part of it has been able to reduce our million tons of carbon or greenhouse gases in the environment. Unlike landfill, where you have 80 times potent of CO2 every over 20 years. So we don't want that. 1-0 landfill. I'll show you a technology here. I don't know if you can see. Let me see. I think you should be able to see this video. Can you see this?
We're Covanta, a world leader in providing sustainable
And you can
waste
hear,
and
right?
energy solutions to
Definitely, sir.
municipalities,
We can hear, sir.
businesses, and industries. If you've ever wondered what goes on behind the scenes at one of our energy from waste facilities, we'd love to show you. We're proud of our modern plants and the people who work here. So come on in. Once trucks arrive, they are weighed and checked in before heading inside to the tipping hall. The waste is unloaded onto the tipping floor and visually inspected for any unacceptable items, which are removed for separate recycling or proper disposal. Waste is then pushed into a storage pit and thoroughly mixed before being loaded into bins, which we call hoppers, where it travels to the combustion chamber. The tipping and waste storage areas are maintained under negative air pressure to contain dust and odors. Once fed into the combustion chamber, waste is combusted at extremely high temperatures in a self-sustaining process at approximately 2,000 degrees Fahrenheit. A typical hopper load is completely combusted in 1 to 2 hours. As waste is burned, the heat converts water in the steel tube-lined walls into steam that rises through boiler tubes where it is superheated. The steam turns a turbine-driven generator to produce electricity, or may sometimes be used directly for heating or industrial processes. The electricity produced by the turbine generator is exported to local utilities for use in homes and businesses. Each ton of waste can generate 550 to 700 kilowatt hours of electricity. Steam from the process is condensed back into water and returned to the boiler tubes, making it an efficient, closed-loop system. After combustion, the volume of waste is reduced by 90%, leaving an inert ash and metal. Remaining ash is beneficially reused or landfilled as non-hazardous waste. Ferrous metals such as iron and steel are recovered using a rotating drum magnet, and non-ferrous metals like aluminum and copper are separated by an eddy current system. Collected metal is sold to be made into new products. State-of-the-art air pollution control equipment ensures that emissions are well below limits to be fully protective of human health and the environment. We neutralize acid gases using lime in a scrubber reactor and inject activated carbon for heavy metal control. We control emissions of particulate matter primarily through a bag house, which employs thousands of fabric filter bags. All flue gas must pass through the bags before exiting through the stack. Throughout this process, the control room closely monitors emissions through a real-time continuous emission monitoring system, controls steam flow, and a number of other automated systems inside the facility. Covanta is committed to providing sustainable waste and energy solutions to ensure no waste is ever wasted. At Covanta, we believe the materials discarded every day should be utilized to their fullest potential to preserve the world's valuable resources and generate clean energy.
So, do you have any questions from the video? Do we have any questions? Let me keep moving.
No, sir.
We're Covanta.
Okay, and that's it. So you can see them, like for the hazardous waste program, you see that everything, both the ferrous and non-ferrous metals, the metals that taken to for automobile companies to use. So nothing is wasted, one. Two, waste to energy. The heat, the steam generated is used to power turbine. And everything, the bag house reduces the emission into the environment, right? So a lot of technology there, and that's different facets. I couldn't touch all because I have to hop into another meeting next 15 minutes, but I'm open to questions. I couldn't touch the other aspect of the PowerPoint presentation, which talked about, let me see. I was trying to show you the scenario, real life model for vapor recovery tower, but I'm open to questions here.
Okay, thank you very, very much, Engineer Walter, for this impactful session. We've learned a lot. We've learned about how to make good use of environment and the rest of that, and also from waste to energy. That was very, very impactful. Thank you very much, sir. So we're moving on quickly to the question and answer session, please. If you have any question, you can indicate. You can raise your hand virtually, or you can type in your question in the chat box. Please, let's do that quickly.
I think somebody
Can
has
you hear
their
me?
hand. Somebody has their
There's a
hand.
question.
Yeah.
There's a question in the chat box too. Please.
Sorry, I wasn't able to see it. It's like I left the meeting a while back. Can somebody read out the question? So I could answer it. And then we'll have the participant raising up his hand to also ask his question after that, Mr. Adoli.
Should I go ahead
Okay.
or should we?
Okay, can you hear me?
Yes, we can hear you. Please, you can read out the question for us, please.
Question. Enoch Oladipupo, he said, okay, I think during the direct air capture video, he said, this is amazing, but did it only extract CO2, that's carbon dioxide, to store for further use or underground? Is more oxygen by any way released with this process? That's the question, sir.
Okay.
Did you hear me?
Yes, I heard you. I don't think Engineer Walter heard you. Sorry, sir. Please, did you get the question, sir?
So what's the question? Sorry, I was in between something.
Okay, should read it out again.
Yes, read that again.
So the question, okay, I think he sent the question after the video, after the direct air capture video. So Enoch Oladipo asked that, did it only extract carbon dioxide to store for further use or underground? Is more oxygen by any way released with this process?
Okay, yes. So direct air capture means you're only capturing your CO2 so it leaves the CO2 in the atmosphere. It only captures more of the carbon dioxide from the air and leaving behind other components. So you have like oxygen left in the atmosphere. Yeah.
Okay,
It's only
so
focused. So the direct air capture system is similar to when I juxtapose your CCUS. So the goal is to capture more of CO2, which is a greenhouse gas, right? But more of the oxygen is left in the atmosphere. So when the process is you absorb you have a big, in the design, you have the big fans blowing this CO2 into the system. Then there's a lot of liquefaction and all that. And in that process, you're going to be dropping off a lot of oxygen into the atmosphere. Before it forms that pellet, goes into the pellet system and starts separating and all that, yeah.
Thank you very much, sir. Enoch, did I answer your question?
yes, sir. Thank you very much, sir.
Yeah, more of oxygen is left in the atmosphere, correct.
Adoli Obandi, please can you ask your question now?
Okay, good evening everyone. Hope you can hear me.
We can hear you, sir.
Yes, I can hear.
Okay, I just want to ask a question concerning the direct air. I just want to ask a question if it can be done locally, because I tend to note that like mostly in Nigeria or mostly in where I stay, that's the northern part, I found out that there is waste, like leaders everywhere. So can it be done locally, this thing that you actually expose us to learn?
Which one? Wait, it's still waste. I'm mixing it up. You said waste or direct air capture. Which one are you talking about?
Yes.
Which one?
The DAC.
Okay, I heard you talking about waste and all that. Okay, yes. So I think for direct air capture, it has to be where you have a lot of wind. I won't say wind per se, air in the atmosphere. You don't want to do it where there's less wind because it's not going to be prevalent. If it's somewhere that is kind of more sunny and all that, it's not going to work. But you want to do it where there's a lot of wind, where it can capture and all that. I think, yes, that's what you want to do. So it's possible, but again, a lot of finance, it's expensive, like you can see there on the juxtaposition. It's not yet, it hasn't even gone into Africa. It's just started in the United States. And again, Occidental Petroleum is the first company doing that, and they've been pushing that over 2 years now. It's been there, but nobody has been looking into it. But now it's almost like when carbon capture utilization started. Now it's now getting more popular in the United States, and it's gradually moving. But it's not. I don't think it's in Africa yet. No,
okay,
it's expensive.
Sorry, I just want to restructure the question. It's actually for the waste energy, but I really appreciate you training. Yeah, this waste to energy. That's the one I'm talking about.
I don't understand.
I'm trying to say, sorry for my voice is actually bad. But what I'm trying to say is that can this waste to energy be can it be done locally? Can it be done locally to a small pilot plant or a small scale that you can do?
It's possible. It's all about finance and funding. So it's for waste. Nigeria, we have a lot of, I think, there's a lot of solid waste, like all the landfill and all that. It can be done. It's possible if there's public funds, public awareness, and the government's ready to fund it. It's possible. It is because you are converting all those things to steam energy, and so if the energy companies are willing to get that as a win-win, converting waste to energy, why not?
I'm actually speaking because I'm thinking about projects right now. It sounds as if it's something that someone can dive into.
Oh, okay, interesting. What are you doing? What's your major?
Chemical engineering.
Okay, yeah, so environmental is a research area, correct? Okay, yeah, it's possible because I did my research was in environmental engineering, my undergraduate degree, before I did my master's, so it's possible. It's just the next thing is you have to. It's about I don't know how you're gonna wrap your head around it. Getting a company that is even focused on waste and working with them on data and looking at how. So that will fall under, I don't know, Nigeria, if they have scope 2, scope 3, but those are standard emission standards. So that will fall under scope 3 emissions, like I said, waste to energy. Yeah, reducing methane gas. Yeah.
Thank you, sir. Thank you very much for the enlightenment.
Okay, thank you very much, Aduleo Bandi. Okay, sorry, sir. I also have a question. Hello?
Yes.
No, okay, thank you. So, the question is also, the CCS, that's the carbon capture and storage, and also the CCUS. Well, there have been a lot of large doubt about the whole process and the rest of that, saying something like maybe it's just a way for the petroleum industry to keep on drilling and excavating for more oil instead of actually looking at the environmental impacts of the world today. So, is in your own point of view, do you think that CCS is actually a very, very good way forward? CCS and CCUS, is it a very, very good way forward, or you think it's also going to be just another excuse to get investment and the rest of that?
I don't think, for me, I don't own an oil company. So if I'm going to speak as an individual in terms of opportunity, I will speak on way forward. Is it going to give opportunity for people for jobs? I would say I haven't seen that impact. Unlike DAC that just came out, I've seen a lot of job opportunities with DAC, direct air capture. I've seen a lot of opportunity with geothermal. But carbon capture direction I've not seen the jingle. So I'm going to talk on based on what young people like us are looking for, right? So to answer your question, is it a way for for the government or people to just exploit in terms of funds? I can answer to that, but I'll answer based on being in the shoes of young people trying to get into the industry. What are the opportunities? Is this a good place to explore? I can't speak to that, but if it's DAC, I would say in the North America, yes. If it's geothermal, yes. I know I've seen a lot of opportunities prop up. I've seen a lot of the job numbers. But with carbon capture utilization, I think it came out, we heard the jingle, but in terms of jobs, to me, I've not seen the job numbers when it comes to carbon utilization. But in terms of, like, to your question, exploitation or making sure, sorry, let me use the right term, like funding and all that, maybe it's another way for them to drill more. I can answer to that.
Thank you very much, sir. Thank you very much, sir. I really appreciate the answer. Okay, so if there's any other question in the chat box, so you can also raise your hand if there's still more questions to be asked.
Okay, I have 3 more minutes. I would like to have a picture. I don't know how you guys do it.
Okay.
Put on your camera and
yes.
Some
So
pictures.
now,
Thank you.
Thank you very much, sir. I really appreciate it. So now we're going to the picture section of the event today. So please, let's all put up a video.
People are very willing to take picture without their clothes on. That's interesting.
So professional of them. Well, it's still beautiful faces. We're still seeing beautiful faces. So please let's put on video. Sorry, I won't be able to put on mine for my hands because it's a really very dark. You can mute the mic. Okay. So please, we're taking the pictures now. So I'll say SP, and we know the slogan: cleaner energies with our thumbs up. So are we all ready? Okay, we're ready. Okay, so 1, 2, 3, go. Your thumbs up. SPE, cleaner energy. Okay, so now we can also like unmute our mics now so that we can say the cleaner energy all together in unison. So 1, 2, 3, go. SPE, cleaner energy. Thank you. Mute our mics now.
Okay. It's nice being here, and I don't know whether the moderator said you can reach out to me on LinkedIn, and the only thing I would just say, please be mindful of the time. Most times people reach out to me at, I mean, United States is 7 hours behind Nigeria. So it's just to keep that. If you reach out to me, I don't respond. It might show I'm online, doesn't mean I'm not responding. It's a busy schedule here. Busy for me. And yeah, because I get those things like, oh, good morning, sir. When I wake up, I'm saying one good morning when I'm in bed. So it's a different timeline, but I'm willing to network and answer questions. So just be mindful of that. I don't respond. Doesn't mean I'm online. I'm not on my phone. I might be flying or something, but I'll get to the message or the connection request. But yeah, a lot of people reach out to me and it takes time. So anyway, it's nice connecting with you guys here. Talk soon.
Thank you very much, sir. Very impactful session, sir. Really appreciate it. And we really love to have you some other time also in the future so that I can teach us more. Yeah, so we can all have a virtual round of applause for him. Let's give a virtual round of applause for him. Can drop it also in the comment box. Let's appreciate him in the comment box also. Yes. Thank you very much. Thank you very much, sir. We really appreciate for you giving us your time. Okay. Okay, wonderful. So, moving on to the next session, we're having a Kahoot session. I think we're having a Kahoot session, but I'm calling on the president of FUTMINA also to direct us on who's going to take the Kahoot session. President Damilola, please, are you on the call? Or is Kelly on the call to take us on the slide quiz?
Yeah, I'm on the call.
Okay. So you can go ahead now. The floor is all yours.
Okay. Thank you very much. Please, can you guys hear me properly?
Yes, we can hear you. Can hear you very well.
Yeah. Okay, please, I want everyone to go to kahoot.com. We are going to play a little game, just answer a few questions based on our speakers' presentation. So just a little game. So go to kahoot.com. Please, if you have done that, just let me know in the comment section so I can drop the pins for the game. So I'm dropping the game pin. I'm dropping the game pin there right now. You can.
Okay. Please, we heard what you said. We should go to Kahoot session. Let's kahoot.com, yeah?
Yeah. So I've dropped it on the comment section. You can kahoot.com. Then if you don't have an account, you can create an account. It's very fast. It's easy to create an account. So, okay, I've seen someone. Okay, I've seen 2 people. I've seen Inyabong. I've seen Alhamni. I'm sorry for pronouncing the name wrong, but Sani. Let me just go with Sani. Yeah, I've seen Sani. I've seen Inyabong. Okay, I've seen oil and gas. I've seen unique of UTMIN. So I have 4 people. Please join. Okay, I've seen Daniel Balogu. We are 19 now. I've only seen 5 people. So you guys should join so that we can finish this game and we know we're almost done for the day. So I'm still giving you guys 2 to 3 minutes. Okay, let's say 3 minutes. 3 minutes, please join. The game pin is already on the chat. You can just copy it. Okay.
Okay. So how are we going with the cow session?
I only have 5 people. Should I start? I only have 5 people and we are 18 in the call. So I'm still waiting. Okay, now 6 people. I'm still waiting for more to join before I start the game. So I only have 6 people. So this is 4:16. This is 4:16. I will start at probably 4. Let's say 4:20. Let me just give them a few minutes for them to join. I have 7 people now. So you guys should join up. Let's do this and we know we are done. Yeah.
Please, can we mute our mic? Can the host please mute the mic of this person?
I have people in the game. Please join up. 4:20 on the dot. I don't want that to join.
Please, Lucy, please, can you mute your mic, please? And
okay. So I'm going to start. Let me start. So I'm starting now. Hope we are ready. Are we all ready?
Yes.
Okay. So I'm starting. Okay. 3, 2, 1. Hope you are seeing the question.
yes, you can see the question.
Okay. Next question. Okay. I have enough.
Please, Obandi, VP, please can you make Kelly the co-host also so that he can share his screen?
I won't be able to share. Let's just continue. I'm using my phone, but the game is on my laptop. So
no problem.
So the second question is yes. Okay. So people are if you guys the top. Okay. The third question. Is it too fast? So this is the third question. Should I wait a little or should continue?
You can continue, sir.
So yeah. This is the fourth question. Okay. So we are going for the last question. It's a true or false question. So okay. So we are done. And we have a winner. We have a winner. So in third place, we have Sunny. In second place, we have Oil and Gas. And the winner is Enobong. Let's give him a visual round of applause, please. Okay, so thank you guys. It was fun having this game with you guys. Thank you, thank you.
Thank you very much, Kelly, for that Kahoot session. It was very wonderful. So we're moving to the announcements section, and to be taken by Okori Emmanuel. Please, can Okori Emmanuel come up to take the announcements? Is Okori Emmanuel on the call to take the announcement session, or we can just move on? Okay. In absence of announcements, we'll be having a closing remark, and we calling on Daniel Balogun to take the closing remark. President SP Nile. Please, a virtual round of applause for him, please.
Thank you. Good evening, everyone. As we come to the close of today's session, I would like to take this opportunity to thank our speaker, Mr. Walter, for his talk. His insights today have shown us how young people play a role in addressing the climate crisis. I also want to thank the chapters that made this event possible. SP Futmina chapter, SP Fupre chapter, and SP Now chapter. Together to create a sustainable future. I hope everyone stays safe and everyone has a wonderful day. Thank you.
Thank you very, very much, Daniel Balogun. So we can now start leaving the call. Thank you very much, everyone that joined. Thank you very much, the participants. Really appreciate you all joining the call today. We look forward to collaborating with other chapters and you guys all another time. Thank you very, very much. We can start leaving the call now. Mary, your voice is cracking. Abi, your network is bad. Can't hear you well. Thank you, everyone. Have a lovely evening. Mary, do you have something to say? That's true, Melissa. Thank you very much. I think you are the one that had the nicest voice today in today's meeting. Took the safety brief. Thank you, Clement. Thank you, Sani. Thank you, Glory. VP, you can end the call. I think you can end the call now.